Okay, so as soon as I place the file in this directory, it read this record. I just printed, I am not doing any calculation, right? I'll clear this screen. I'll try to place the another file. So user data set 2. I'll just place this into here. So now it is going to take this file. So it has taken the file which I kept it there. Right. So this is how the CSV file source works. Let's do some aggregate or some query after consuming the data, which we'll do in the next file source. So basically JSON file source will do. Okay, what we'll do is, again for JSON also, we just define a schema, right? So schema is must for the streaming application. Okay, that's mandatory. So you need to define schema, and it's JSON and the CSV. The only difference is basically the format. You just going to change CSV to JSON, and we are going to consume the data, and we'll try to do the group by. So basically, we'll try to find out the number of users registered on the different countries. So basically, data frame dot group by of country, and you say count. So it is going to give you the count for each country, and I'm going to order based on the count in ascending, in descending order. Okay, so ascending equal to false, it's going to give the descending order, and I'll just limit only the 10 records. Okay, and that I'll just put it on the console. So console sync is used, and I'm using the complete output mode, and I'll put the trigger interval as 10 seconds. Any question on this? So basically, the structure of the program is this. So it depends upon the different file source and syncs. There are few things you have to change, but the overall structure is same. So any question on this? I assume there is no question. I'll just move forward. So let me run this program. I'll go to the directory. I'll just pick it from, okay, JSON. There is no data as of now. Once it starts, I'll place this user data set one.json. The application is started. Now I'll place the input record. So I'll copy the user data set one JSON. I'll place it here. So I'll just keep the batch interval as I think 10 seconds at here. I'll just clear off. Just So it processed. So you see China has more number of user registration, Indonesia, Russia, so different countries, right? So this is the first batch in output. So since we are using complete mode, I will put one more file and you see there will be an increment in this countries based on the number of users registered. So I'll just go there, JSON folder. I'll place one more JSON file in that. I'll go here, place this. Let me wait for the next batch output. I just cleared out. So I think China was having 189. Let's see how the order was China. So it is incremented to 362, Indonesia 186, and Russia. So it works as expected. Complete mode also works on the entire data set, and the different aggregates are working as per the code we written. Okay, so I hope it is very straightforward. Let me know if you have any queries. I will stop this. I will go with the next file format, which is welcome to ORC file format. ORC is nothing but optimized record columnar. Okay, it's one of the file format. It's one of the optimized file format for the big data systems. What they say is basically columnar. It organizes the data in a columnar. Basically, different column informations are stored in separately as a file system. So that retrieval is faster compared to storing your data in the form of horizontal way. So generally, when you store a CSV file, you see this one records. The horizontal refers to one record, right? It's basically one row. So row wise, we store that row into horizontally. What they do in a columnar data structures, they stores all the records which is there in a particular column in a separate segment or group, so that whenever they try to query a single column, it is always faster. So that's what they say. So that is, so one of the optimized file format is ORC. So how do you read that ORC file? That's what we are going to see. The template is same. So you just create a function object and just create a schema. So when you read a stream from the ORC directory, you just change the format into ORC, provide a schema, and as usual, defining a sync. So sync is going to be console sync, and update output mode I'm using update, and there is a one more property you see I introduced here, which is called checkpoint location, and I just provide in the same local path I just provide on directory. You just create one directory in this wherever I have this program. Okay. So what is the use of checkpoint? Checkpoint keeps track of the information or metadata about the streaming your job. Okay. So each trigger interval, what data is retrieved, right? So all this metadata is captured in this location, whatever the location you provide for the checkpoint location. If, say, example, your application is abruptly stopped, so if you want to restart from where it is stopped, so this is the very important features, which is a checkpoint location. So I just provided here. With this, I will start this. I'm not providing any aggregate query or something. It just reads the data and print it here. I'll just run this. ORC binary, this also this data is more of binary structure. You cannot read it. If you want to read, I try to open and text editor, it will be binary. It is. It's not actually. It's a not human readable, but it's a binary format. I'll just close this. What I'm going to do is I'll just remove this and keep it in a separate folder, or I'll keep it here. I'll copy one ORC file. Getting application started. It's already picked from those location since we have data there, right? I'll just clear up this. Try to place one more time there. Just a minute, I'm getting on. Okay, so not picked out. Okay, so you see there's a checkpoint location. Can stop. Remove this also. Okay, now I just go and remove it here. And start it again. I think since it has earlier like two files was already there in the directory and it captured in the as checkpoint. I think that's what it did not pick. So let's verify that. So now I'll go and place it. ORC file. So I just given the trigger interval as 10 seconds. Let's see. Oh my god. Yeah, so it took the data, streamed and it's showing the data here. I will try to place one more file.
Sorry, how to generate that ORC file?
Basically, what you can do is I took from some internet, but you can write it into, say, example. 1 minute, I'll just tell you. Copy this. ORC2. Place it here. You should see next batch you see. So basically, yeah, so data is coming in. So I took it from the internet, but if you want to generate, either you can use like pandas like program to generate. Like you can use pandas data frame if you have a data any data set if you have, and you can read the pandas data frame and write it into ORC. That is one way, and uh, uh, even the Spark API also we have right. You just read it as here. I just where is that program in batch API? Right? You just read CSV file, and while write, you can use the ORC format as a target. So that is also one way. Uh, write dot. So ORC is there. You just give the path here. So the only problem is when you write it into using a Spark API when you write, so you will get a folder. Under that folder, you will have the files in a partitions because number of partitions you have in a data frame. So that many number of files it will be there. If you want to make it as a single file, you need to apply the coalesce, and it will have the file name as the GUID with the partition ID. I hope you understand that, right?
Yeah.
Yeah. So, if you want to use, if the data is huge, anyway, we have to use a Spark API. If the data is small, like what we are used, so you can use Pandas data frame. That also, I think it supports ORC. Or you can use other libraries if it's there in the Java or Scala. Okay. So the last file format is basically, let me just stop this. Parquet file format. It is also one of the uh, compressed file format. So it uses the compression technique Snappy, which is one of the popular compression techniques in big data system. So it compresses the uh, data into, it gives you around 60 percentage of the compression rate. So if you have 100 MB, so you'll get when you do compression using Snappy, you get the file size of 40 MB. So that file format, this file also you can actually generate using a Spark API, or you can use the pandas. Okay, so I have a sample files. I'll just run this program. I hope this is most the structure is same, right? So you give the Spark session object, schema, definition, and then Spark dot read stream of Parquet format with the path. So Parquet file format basically it will have a schema by its own. Okay, so if I run without schema, let's see what happens. I think it has already data there, it picked up. Okay, so it actually did not do schema, right? So I'll stop this. I'll go to the, say example, CSV. This. Okay, JSON. Just remove schema here. We'll run this. Basically, this JSON file. So it says a schema must be specified while creating a streaming source data frame. So its schema is needed, but it was not expecting for the. I'll just revert back this change. But Parquet is not expecting the schema. Okay, so this is how the file source for different file format works. I will continue the next file source, which is the Kafka, which is very important tomorrow. Okay, so have I discussed Kafka earlier? I don't know whether I discussed or not.
No, Pari.
Okay, so before starting the Kafka source, I will just give you the uh, like it's because anyway I have to cover that Kafka. So first I will cover Kafka because in Kafka there are two main concepts: producer and consumer. Uh, People who publish the data is called producer. Uh, Publish the data to the Kafka are called producer. People who consume the data from Kafka they called consumer. So we'll discuss on Kafka first, and then we'll start the Kafka source. Uh, so then we will complete. Then we'll go with the sync. I think sync is going to be very straightforward. Once you cover the file sources, so sync is we have only file sync and Kafka sync, right? And we have for each also. We'll try to write it into some MySQL database and try it. Yeah, that we'll do it tomorrow. Tomorrow we'll focus on Kafka first and followed by the Kafka source. Okay. So do you have any questions? Please practice the examples. I will upload this exercise as well in the Git. Any question you have?
No, Pari. Very good.
Okay. Thank you so much. We'll sync up tomorrow morning at 7 a.m. Please practice all the examples. I'll just forward you. I'll just give me a couple of hours. I'll just push it and share it. Yesterday it got late. Sorry for it. Today I will send you to soon. Okay. Thank you so much.